Good morning, everybody. Talking to you today here about getting the most out of malt barley. It's a pretty critical time, I think, in malt barley right now. There's only been a few major transitions in varieties over even my lifetime. I think back to when I was growing up. We had Harrington was the one we had on our farm out in west central Saskatchewan, and I just in the early 2000s was taken over by AC Metcalf, and then a shift to CDC Copeland here more recently, and both Metcalf and Copeland were registered in the late 20th century, and so they've been around for a long time, and we're seeing now a transition where there's been more new varieties coming out that seem to have caught the eye of the maltsters and the brewers, and so we undertook this project. Started back when I was with the Ministry of Agriculture, worked with Sask Barley, and now I'm actually working for Sask Barley, so I get to continue working on this project. And the idea of it was to take some of the work that had been done by and led by John O'Donovan and a lot of good research scientists with Ag Canada. It really cemented some of what we know about agronomy for malt barley research, and started to look at them in agronomic packages rather than compartmentalizing or looking at two or three different treatments at a time, and adapting them. And so we can compare how those packages work with the old standard AC Metcalf, and looking at the newer varieties and how they fit in there, because there's a lot of potential in these new barley varieties. So I think it's a good opportunity for growers to check them out, and there's still good malt contracts available. And for a year like this, where feed prices are so high, there's a potential where you can really push some of these agronomic practices, and see how it goes. And if you did happen to get knocked back into the feed category for some reason, then it's not such a hit as it sometimes can be. Usually you see a pretty good premium for malt, but it's definitely good for barley growers when you've got a strong feed market as well. So this project had just its first year in 2020. So we're looking at pretty preliminary results. The project consists of two different experiments, which I'll get into in a minute, and it's growing at 5 locations around the province, plus one field scale demonstration. So we've got the Northeast Ag Research Foundation, NARF, at Melfort, the East Central Research Foundation, ECRF, at Yorkton, Wheatland Conservation Area at Swift-Current, Conservation Learning Center, CLC, at Prince Albert, and Warwick Western Applied Research Corporation at Scott. The varieties that we're looking at in the study, in the experiments 1 and 2, are the old standard AC Metcalf. What has been looking to be like the next variety that will become a high acreage variety. It certainly has grown significantly in the past few years. AAC Synergy. And it really just came into its own here in the last couple of years, starting to take some of that acreage away from AC Metcalf, which has been sliding on the acreage surveys or crop insurance insured acres data that we could look at from the Grain Commission that they compile. And so, yeah, good to see a high yielding variety like Synergy coming in there. And it's got definitely some improvements in disease, which we'll look at here in the next slide. CDC Bow is another one, pretty good interest from maltsters and brewers. So those are 3 varieties that we're looking at there. And then in the field scale project, we went with CDC Fraser. That was the one, the primary of interest to the grower. So we worked with him on that. And so they pulled this data out of the current varieties of grain crops, so Sask Seed Guide publication. So Synergy is the check, and it switched to be the check here a couple of years ago. It kind of made the relative yields of everything else look a little bit lower than they had been when it was compared to AC Metcalf before. It's certainly one of the higher yielding ones out there, but Fraser's right up there neck and neck with it. Maybe a little bit lower in the northern environment, but right in southern part of the province, right neck and neck with Synergy. And these varieties, they're competitive even with higher yielding feed varieties. at least until you get up into the really high fertility rates. And so, yeah, talking about the yields, obviously Metcalf's yield potential is a little bit lower than these. Bow's kind of in between. And then the one of the primary reasons we selected Bow was that what we're starting to see in some of the new varieties is a notable improvement in the lodging rating. So one of the risks of malt barley, if you're going for a little bit higher fertility in amongst issues like protein that can arise with going for malt, um, is the risk of lodging and losing some of that yield potential. Barley is certainly prone to lodging, but yeah, notable improvement here in Bow. It's there in Fraser, but for the purpose of our experiment, we wanted to show what could happen with a variety that has pretty good resistant to lodging. It's not to say that a variety that's rated a VG, which is the highest rating we have for lodging, it's not to say it won't lay down. It's just going to resist better than the varieties that are rated lower, like a good or a fair. And the other thing we're seeing with these new varieties is generally a stronger disease package. Synergy's got a pretty strong one compared to Metcalf. Fraser's probably the strongest of the four that we looked at. There's one, the root rot issues that maybe it's a little bit weaker on than what Metcalf was. Synergy's kind of right on par with it. But in general, seeing a pretty good disease package there for these new varieties. So I'll give you a breakdown of the experiment, and as I go through it, I'm going to talk about the rationale as to why we selected these treatments, and give you kind of an insight as to what was coming out of that work that was happening kind of the mid 2000 to 2010 decade and the early part of the 2010s. Some of it continuing a little bit later than that, but most of it done in that earlier period. So that was that work that John O'Donovan led through the barley cluster. It's really great work, but now it's getting to the point where it was done on older varieties, and we're going to see how they stacked up to the newer varieties. So pretty basic treatment, relatively conservative seeding rate, 200 seeds per meter squared. The 90 kilograms N per hectare, that rate was selected based on O'Donovan's work, where they pretty consistently showed that the fertility rate was topping out about 90 kilograms per hectare. Not much benefit in going beyond in the work that they had done. And plus, if you look over on the top right of the slide here, certainly for Metcalf, as you get up above 90 or certainly to the 120, you're getting about that 12.5% that is generally the upper end of the limit for domestic and export malt, with the exception of the Chinese market, which has grown considerably in the last few years. They're accepting more upwards in the range of 13%. There's heard of a few examples where a grower can get a malt contract that's going to China for a higher percentage point, so they're probably blending that down with some lower protein stuff. But generally, China is accepting of a little bit higher protein content, but our domestic stuff not going beyond that 12.5%. So with the older varieties going above 90 kilograms per hectare, that was getting to be a bit of a risk. So we ended up with 7 treatments. I'm going to go through them here one at a time, adding them in. So we went from a low seeding rate to a seeding rate that was recommended after O'Donovan's work, bumped up that fertility rate, and a couple of reasons for that. So we're looking at the new varieties. They've got higher yield potential. They've got lower protein in general. And the other thing is that O'Donovan's work, it was done on Egg Canada stations. And one of the concerns that I sometimes worry about is if that rate of 90 kilograms N per hectare is taken too literally and not compared to and experimented with on farm. Those Egg Canada stations, they're generally on pretty top-notch soils, and so there's a potential where they've got a supply rate of nitrogen that's going to lead them to maxing out their yield potential at a lower nitrogen rate than you might see on a different soil type. And so we learned about lots of different soil types from Angela there. And so experimenting a bit with different fertility rates on farm is a good idea. But yeah, we wanted to see also the yield potential of these newer varieties. Also bumped up the phosphorus fertility rate and added some potassium. Generally thinking that the phosphorus fertility could use a little bit of a boost, and the potassium may offer some assistance with the lodging if that continues to be an issue. It can lead to improved stem strength in some circumstances. So this is the seeding rate data that O'Donovan had generated. And so you see that the yield is certainly topping out. You know, definite benefit for going from 200 to 300 seeds per meter squared. Now they're talking about live seeds per meter squared that they're planting here. So their emergence were generally in the 200 to 220 plants per meter squared, so 20 to 22 per square foot. And so, you know, the other thing that they looked at here found that kernel weight was decreasing as you went through the seeding rates towards the increasing rates, but still in an acceptable range of 300. They also generally found that uniformity increased as you got to these higher seeding rates, and so it seemed to be optimized around that 300 seeds per meter squared. Definitely, as you go up, like at that low seeding rate, you're seeing close to 100% emergence. And by the time you get up to that really high seeding rate, you're down closer to 50%. So a lot higher mortality at those higher seeding rates, but clear response there at 300. So the third treatment, we added it in a seed treatment, otherwise the same as treatment 2. The fourth treatment, this one, it dials back the nitrogen a little bit, keeps the seed treatment in there, and adds in head blight, Fusarium head blight timing for fungicide. So this is one that we thought it might be a pretty conservative approach to a new variety. You know, it's going to see lots of farms that are going to put a seed treatment on. I think a willingness to go to a higher seeding rate. That nitrogen rate may be a little bit more leery. So we wanted to see how that stacked up against these higher N rates with a strong disease management package from the seed treatment and the fungicide. The treatment 5 gets us back up to that full nitrogen rate. And so comparing 4 to 5, you just have that one difference. And we go back to treatment 3, we've got the fungicide in there, Fusarium head blight timing. Treatment 6, we're adding in a plant growth regulator. And it wasn't registered last year, but it's registered now for use on malt barley. Of course, first time use of a product like that, you'd want to check very closely with your malt contractor to see whether or not they're willing to accept barley that's been treated with a plant growth regulator. But because the potential is there, and because of some work that was a little bit more recent here, so this was Tideman. It's a kind of a carryover from some of John O'Donovan's work. So Brienne Tideman is with that Ag Canada station out in Lacombe, Alberta, and led this project. So their Trinexapac ethyl is of course Modus. And so the reason we picked it here is because their work, they found that it led to the largest number of lodging reductions, and the magnitude of those reductions was largest using the Modus product. They found it reduced plant height, which is not unexpected for a PGR. Bit of a maybe a negative that it's also reducing some kernel weight. But yeah, the precaution, of course, of the PGR is I think the way they worded this, and they kind of kept that consistent here, was that it's not going to work in all environments to solve the problem that you're looking for. And so you take it with a little bit of caution. And so we used it only in a couple of our treatments. And so you'll see that it continued through into treatment 7. And the other major difference here is that we added that flag leaf fungicide timing as well. And so the rationale behind only one of our treatments having that flag leaf timing was that some of the more recent work that's been done by Kelly Turkington, again out of that Lacombe, Canada station, found that there doesn't seem to be a yield advantage applying that flag leaf timing and FHP. So a single application at FHP timing seems to be sufficient in most cases. It had an article on that, so links down there. You can look on the Sask Barley Commission website. You can look on the Alberta Barley. Has the same kind of information. More work done on this in the wheat area, but it seems to be pretty consistent across crops that there doesn't seem to be that benefit to doubling up on the fungicide application. So if you're planning an FHB application, it seems to be effective. But we wanted to see if we're really pushing those inputs, if that flag leaf fungicide became effective again. So a second experiment, which I alluded to earlier, this one's a little simpler. It is just a straight nitrogen rate application to see where the upper end of these limits are. So this is based on some work that East Central Research Farm, our foundation, pardon me, out of Yorkton had led with the agroarm sites across the province. And they had found at some pretty high nitrogen rates, not quite exceeding 200. I can't remember if it was 150 or 180 was their high rate, but they were still seeing response. And so we wanted to see what the upper end of the scale was, since we added that higher rate on for these to see how they performed. Would fully expect that some of these really high rates to run into some protein issues. We wanted to find out where that was. Field scale trial was with CTC Fraser, as I mentioned. And so we went with what the producer had normally been doing, and then an enhanced practice. So we had bumped up the nitrogen, a little bit more phosphorus, and added potassium to it, as well as increasing the seeding rate. So we see some preliminary results, and of course, with preliminary results like this, 1 year of research, you got to take it with a big grain of salt. You want to be cautious as to what you're taking home from this, but just wanted to share with you where things are at now, and what we're looking at and what we're hoping to see over the next couple of years of this project. So, across all varieties, all locations, all treatments, Synergy stands out as the high yielding variety. Obviously, it's not quite as big of a yield jump as what we see in the variety guide. So, that's going to vary obviously from location to location, year to year. And so, I'm not saying that the variety guide's wrong with this few sites we've added of data, but if we're dealing with malt production, that maybe that upper end isn't quite seen there with the Synergy yet. So, but certainly draw your attention here to the protein levels. Clear indication that the protein of these newer varieties is lower, and so there's room to push those nitrogen levels a little bit further. So this one, this is across the management treatments. So I had treatments 1 through 7 before. This is A through G. And just as a reminder, there's this chart down at the bottom to give you the breakdown of what those inputs were. And so we start at the basic simple treatment, and clearly this one is not performing as well as any of the other treatments that we've got. And then we went to that one that was treatment 4. So the higher seeding rate, it's got the seed treatment, but not the higher rate of N. And so it's definitely better than the basic treatment. So there's definitely a response to nitrogen and seeding rate. Specifically one or the other, I guess we don't know that in this case, but and we go then next step, and this treatment 5. So this is if I was thinking about it beforehand, might have guessed that this might take the edge, and I can say it's preliminary results. So we'll look again after a couple more years. But we've got the highest seeding rate, we've got the seed treatment, we've got the high N rate, good phosphorus potassium fertility, and that Fusarium head blight fungicide timing. And so while this is not statistically significantly higher than these other high input treatments with the high seeding rates and the high fertility rates. It's darn close. And so if we look at it compared to what the lower one is, we're getting into a range where we're approaching that LSD. So I'll be interested to see if that evolves over time to be a significant difference in those treatments. So treatment C, that's still got the high seeding rate, but it doesn't have the Fusarium head blight fungicide timing. So maybe a benefit there. Thinking back to the year a bit, most of the locations that we had, they were below normal precipitation, so a bit more on the drier side. The Yorkton site was really dry, so they ended up with some lower yields than we'd ever expect to see at Yorkton. And so I think the Scott location was the only one that had above normal precipitation. And so, if we get back into a bit more precipitation, we maybe see that there's a bit more of a benefit to that fungicide. Okay, so on to experiment 2. You can see there's definitely some yield response happening here. It definitely is, though, also leveling off. You get that exceptionally high infertility rate. Metcalf is actually still increasing too. Keeping up pretty steady until you get to that very high nitrogen rate. And I should point out too that this is a soil test N plus fertilizer, and so it's consistent across all locations as to what the available N was. Then get into protein, and there's where we start seeing that separation of the potential for working with these varieties for high yield. Even at the 120 rate, Metcalf has gone beyond that 12.5% threshold. So it might get you into that Chinese market, which is a big market. But when you can start considering some variability to that, well, then going to that higher rate presents some definitely some calculated risks with a variety like Metcalf that are a little bit more managed with Synergy and Bow, where they're not getting up to that 12.5% until you get up into that approximately 150 kilograms nitrogen per hectare. Okay, and then just a quick snapshot of the field scale experiment. So this is with the CDC Fraser, and so pretty positive results. Producer was, I think, maybe a little bit concerned about going to that high nitrogen fertility rate, and so this is the same where is soil plus added fertility for a total 120 kilograms N per hectare. We bumped up that phosphate and added the potassium fungicide across the board. But yeah, about a 10 bushel per acre yield gain was the estimated yield on the 2. And so this one, we had the field just split right down the middle, and we're able to take a whole yield estimate off of each side. So pretty impressive results. And so the grower is pleased and is thinking about increasing that agronomic package for all barley acres here next year. So leading into a quick summary here of what I've been talking about this morning. So we can definitely see that all varieties are responding to that increased level of management. What we might see evolving in these practices, which I wasn't really able to show today just because of its preliminary data, and the environmental analysis hasn't been completed yet. But and it's not unexpected, but we might see different management practices evolve as being more favorable for different environments. Protein levels in this case were generally pretty acceptable, even up at that higher rate in the experiment 1. In experiment 2 with the Metcalf, it was getting beyond, except for that Chinese market. But yeah, like I said, add some variability in there and potential issues in some areas. Lots of response to nitrogen, but you can't push it too far because protein will start to become an issue. The other one I didn't show here, but I did definitely see in the data set that I was looking at for this, depending on location, starting to see some reduced emergence at those really high N rates. So a little bit of burning of the seed row seemed to be the case. And so taking this back to your own farm, I really think these new malt barley varieties are worth a try. There is malt contracts available for most of these varieties all of these varieties that we used in our trial, but there's also other new varieties like AAC Connect um, that are out there, and we just got limited in what we could try for these new varieties. We'd love to showcase them all in these higher input agronomy trials that we did, but we just ran out of room, get into a lot of treatments pretty fast. And so the new varieties, they definitely do offer some opportunities over old standard like AC Metcalf to increase that agronomic management. And I think as we watch this experiment of Barley Max to continue over the next 2 years, I hope to see some specific management practices become even more apparent than what they're looking to be after just 1 year of research. So that's my presentation for today. So I thank you and for your attention, and thanks to Sask Canola for working with us to deliver this. They certainly took the lead on getting the information out there to people, and really appreciate the opportunity to work with them to bring this presentation to you.
So this to Mitchell, the malt barley fertility research. What has the optimum pounds of nitrogen per bushel been for the newer, higher yielding varieties, taking into account the soil test and?
Yeah, that's a really good question, and unfortunately, I don't have a direct answer for you. I haven't seen that off the top of my head, at least in any other research that's come through. It's certainly one that we will be able to calculate through the Barley Max project, but this is these are pretty preliminary data that I was presenting here today. So that one is not one of the metrics that has been looked at yet, but is certainly going to be worthwhile taking a stab at as more data comes in over the next couple of years. I guess the thing that I would say about it is what we did see in some other work that Amy Mangan had done in Manitoba with wheat, was that although there's certainly some site-to-site variability, that those old standards that we saw that the Canadian Fertilizer Institute made available way back when that type of work was available. And so if you can find their uptake and removal rates for different crops, that old little fact sheet that they had, it give you a crop and a yield and the amount of different nutrient components of nitrogen, phosphorus, potassium, and sulfur removal and uptake for each of those crops. And that's a pretty handy tool. So if you've got to get your hands on that, that'd be good. It is available on the internet, but if not, you can email me. I saw it went up to the chat. I do have a copy that I managed to scrounge. So yeah, that work that I was mentioning about Amy Mangan, like I said, there's some site-to-site variability, but even with the newer higher yielding wheat varieties, they were seeing that it was pretty consistent on average with what that older work was that the CFI had.
Thank you. See, we've got 5 minutes left, so I'm going to sneak in one of my own questions here to Mitchell. So as you increase that seeding rate, your seed size gets smaller, but plant growth regulators also have make that seed size go smaller. So if and thinking of the lodging, I mean, if you have a higher seeding rate, your lodging might increase. So can you have a stacked effect to where might you run into problems for malt quality with seed size?
Yeah, I guess that's one of the things we're looking for, because I didn't mention it in the presentation, but part of the work that is done with the Barley project is all the samples from experiments 1 and 2 and the field test are into the CMBT. They're going to do the malting analysis for all the barley, and then they're actually going to go through and from experiment 1, they're going to run micromalt testing on it, and so they're going to get a really good idea of how the different treatments are impacting the malt quality. And so I think we'll get a pretty good indication over time. That's not one that's specifically been looked at yet, Keith. And I'd have to go back and look at that paper too that I mentioned of Brianne Tideman's that just came out here last year. Because I think that in addition to looking at PGR, they were also looking at seeding rate, and so to see whether they had any, like you say, a stacked effect that kind of worked against you on that kernel weight. Yeah, so it's something that you definitely would want to watch.
So that seems to wrap up our questions. Is there, I guess, for Warren or Mitchell, is there any other information that maybe you think you might want to comment on for our listeners here today? So that seems to wrap up our questions. Is there, I guess, for Warren or Mitchell, is there any other information that maybe you think you might want to comment on for our listeners here today?
Yeah, and I guess the final comment I'd make is that, obviously these newer varieties have opportunities for enhanced agronomic management and including higher N rates, but there's going to be site-to-site variability, and so some farms are going to have a higher N supply rate in their soils, and so I wouldn't recommend to somebody to just jump in whole hog right away and put all their malt barley acres into this and see them run into an issue with protein or what have you. So if you're going to adapt a practice, to test it out a little bit first on your own farm, because there is going to be variability. The research we do is it's there to show what the potential is, but it still should be managed for each individual farm. It's going to be a little bit different everywhere.